All right, this is on simplifying radical exponents. A rational exponent is an exponent that can be written as an expression m divided by n, where m and n are both integers and n cannot equal 0. Radical expressions can be written using rational exponents. So in this box here, it shows you the first, in the words, the exponent of 1 divided by n indicates the nth root. So then there's an example of 16 to the 1/4 power can be rewritten as a radical of the 4th root of 16, and then you can reduce that down. As a property, it's a to the 1 over n, and that's going to be the nth root of a. The second one, the exponent of m divided by n, indicates the nth root raised to the mth power. So then there's again another example. And then here how you can use it. All right, so let's go ahead and simplify. Write the expression in radical form and then simplify. So we have a power of 2/3, so we're going to rewrite. Remember the denominator, if I go back up here, the denominator of the rational exponent becomes the index of the radicand. So our denominator is 3, so that'll be our index. And then we have negative 125. And now we can choose to write that power either underneath like this, or we can write the power outside. You can use either one. So I'm going to go ahead and now simplify this. So that is negative 5 times 5 times 5, or negative 5 all cubed, and then cube root of 3, and then it's all raised to the second power. So cube root of negative 5 cubed is negative 5, and then we're raising that to the second power, so negative 5 times negative 5 is positive 25. All right, our next one, our index is 3 because that's our denominator, 64, and then raising it to the first power. So then we go underneath the radical, and we're going to rewrite that 64 as 4 cubed. And we really don't need that 1 outside anymore because it's just going to be itself. And then the cube root of 64 is 4. Next one. Now we have a index of 2, that's our denominator, and then 4, and then our power is 5. So the square root of 4 is 2, and then we have power of 5, so we get 32. And notice that index is an even, so we'd have a plus or minus 32. All right. The 4th root of 7 cubed, we're going to rewrite this using rational exponents. So the index of 4 will be our denominator, so we get 7 to the 3/4 power. 11, our index is 3, so that's our denominator. And then we're going to simplify that power as 11 squared, and then 11 times 11 is 121. Next one, we're going to rewrite that 81 as 3 to the 4th power. And then the 4th root of 3 to the 4th power is 3, plus or minus 3. And then we're raising it all to the 3rd power. So we get plus or minus 3 times 3 times 3 is 27. Continuing on, 13, and then our index is 8, so that'll be our denominator. We're going to reduce that fraction. 4 divided by 8 is 1/2. Next one, 13. Our denominator will be 5 because that's our index. We're going to reduce that fraction. 15 divided by 5 is 3. All right, here's some properties of rational exponents. We have the product of powers. Where we add the exponents. We have the quotient of powers, where we subtract the exponents. We have the power of a power, where we multiply the powers. The power of a product, we distribute the powers into each base. And the power of a quotient, again, we distribute to both bases. All right, rewrite each expression using the properties of rational exponents. So notice that these bases are the same. They're both base 25. And what we're going to do is we're going to add those exponents. So 3/5 plus 2/5. The product the product of powers is what we're using, this first one, because the bases are the same, so we can go ahead and add those exponents. And then we're going to simplify those powers. So 3/5 plus 2/5 is 5/5. And then we're going to simplify the fraction. 5 divided by 5 is 1. 25 to the first power is 25. The second one, our bases are the same, but now we're dividing, so we call that the quotient. So the property we are going to use is right here, called the quotient of powers. We're going to subtract those powers. So 8 raised to the 1/3 minus 2/3. So 1/3 minus 2/3 is negative 1/3. And then we're going to go ahead and flip that 8 down to the bottom because we don't want to leave a negative exponent. All right, then what we're going to do is see if we can simplify that 8 to the 1/3 power. Our index is 3, and then we have 8 to the first. And then the cube root of 8 is 2. And the reason why that is you can take that 8 to the 2/3 power. All right, next example. They're the same base, so we can go ahead and add those exponents. So 3/2 plus 5/2. Add the fractions, so 3/2 plus 5/2 is 8/2. Then reduce our fraction. 8 divided by 2 is 4. And then we can go ahead and enter that into our calculator. So 4 to the 4th power, which is 256. All right, our next one, we have a power to a power. So we are using this one right here, power to a power. We're going to multiply those powers together. So we're going to multiply 1/5 times 1/3. We're going to multiply those fractions across. So 1/5 times 1/3. You multiply the numerator pieces and then the denominator pieces.